Okay, hi. This is the first class meeting of College Physics 1. A lot of you guys have already had lab. Usually what we're going to do during this class meeting is I'm going to answer questions that you have, and we're going to work through problems together in group. I'll do some problems up here so you can see how to do them. You'll work on some problems together. And then the lectures and the notes and stuff will be given on YouTube and D2L. Every week, if you look on the main announcements of D2L, I haven't done it yet, but I'll put up stuff for you to, which videos to watch with links to them, notes that you can take notes in the margins of, and that's going to be sort of the format of this class. Today I am going to get into a little bit of material since we can't work on any problems or anything yet. But most of the time, I'm not going to do any lecturing at these class meetings. We're just going to work together on problems and answer questions and stuff like that. So today, I'm going to go through the syllabus first, talk about the structure of the class, and please stop me if you have any questions as I go. And then I'll talk a little bit about unit conversion and just get into the first topics that we need to get into for this class. Okay, so for the syllabus, if you go to the Normandale webpage, you can get on D2L that way. And once you're into D2L, if you go to your physics page, I said this in a couple of the lab sections, but let me tell you all while we're all together. So you're not all in section 11 of physics. There are 4 different sections of this physics. In D2L, though, it looks like you're all in section 11 because I just moved everybody into that section because I'm giving the same assignments and everything to everybody. So if you're in, say, section 14 and you're confused about why your D2L says you're in section 11, that's all it is. You're still in the same section you signed up for. Okay, so there's the main physics page. And the first thing you see when you go into the main physics page is the announcements. So anytime I give a new assignment or choose a new lecture or notes for you to look at, I'm going to put something in the announcements. So that's the thing, that the announcements is what you should look at maybe once a day or whatever. Just make sure you're not missing anything. Any updates I need, I'll always put something there that'll at least tell you, like, okay, go to this section and find this thing. Okay, so announcements will always tell you what's new, what's going on. Okay, and later in the semester, if there's ever like snow or whatever, and you want to see if a class is going to happen or not, there is a school number for class cancellations, but you can also just look on the announcements, and I'll have something on there if something like that happens. Okay. So the announcements are where it'll tell you what to do. Almost all of the stuff that you'll need to get to do, to follow those instructions are in the content section of D2L. And so if you look on content, there's course information. That's where the syllabus is. I'll go to that in a second. The lecture notes, these are companions to the YouTube video lectures. And you can go to any topic in here. It's broken down into sort of chapters. Let's say we want to look at the part that's on 1D particle kinematics of free fall. Um, and what you see here is my writing that's going along as I'm doing the video lectures. So, and the videos, what you see is the cursor going along and you hear my voice. So this just goes right along with the lecture video, the corresponding lecture video. And you can take your own notes, which, you know, it's really just your preference. You can take your own notes while you watch the video, or you can print these notes out and have them in front of you and then just jot little things down in the margin as they come up to you. Some people like to do that. If you don't like it that way, then that's perfectly fine. All of the problems that I'll assign just for the daily assignments are here. So you can go to any one of these topics. The chapters correspond to the chapters of the chapter numbers correspond to the chapter numbers of the notes and the lectures. And you can just see all the problems that we'll be working on in that under that topic. And for every one of those problems, there is a solution. So the idea is, as you go through those problems, you should try to do it without looking at the solutions. But in case you get stuck, you can look at that, get a hint of how to proceed, and then go back and try to do the problem without looking at the solutions again. It doesn't really do you any good to work on problems, you know, to sort of copy down my work. What you need to do is figure out how to do the problem on your own. And if you understand the thought process for these problems, then you'll do well on the bigger assignments and on the exams and stuff like that. So the solutions are just all handwritten. It's just me going through the steps of how how in class we talk about solving these problems. And then the labs, I don't know if I have, I don't have any up yet, but next week we'll do our first lab activity. And before that, I'll put a lab up here. You don't have to do anything before the lab. You can just show up and we'll start at the start together. Okay, but for now, for today, what we want is the course information and the syllabus. Okay, so this is the structure of the class. So there's 4 sections, 11 through 14. Each section has a lecture and a lab. Well, I guess you're the ones who understand this for sure because you're here at the lecture. The people who need to hear this are out in the corridor somewhere. This is the lecture for sections 11 and 12, and then the corresponding lab time is underneath. And you know what I was saying about D2L, this is why I don't want you to get confused about what section you're in. Even though in D2L it says you're all in section 11, that's not the case. So, but by the way, if none of our labs are like jammed full. So if you ever can't make it to your lab during the week, look at that schedule and see if there's one of the other 3 labs that you can make it to. And if you can do that on a week that you can't make it to yours, that's perfectly fine. You don't have to let me know ahead of time or anything. Just show up and it'll work fine. So this is my contact information. The best way to get a hold of me is email. I'm checking that several times throughout the day and in the evening. My PhD is actually it's not in physics, it's in engineering, sort of engineering math. That's my area, but there's obviously a lot of overlap. For office hours, I have 3 office hours scheduled a week, but I'm also assuming that that with a lot of people still taking classes online and this class being semi-online, and I'm sort of planning on, in addition to those 3 hours, just scheduling a lot of one-on-one meetings with people. So if you want to talk about something, you have a question, whether it's a quick question or a long question, either one's fine. Send me an email and we'll either schedule a time to meet or we'll decide on a time to talk over Zoom. When we decide on a time to talk over Zoom, I'll just email you a link for that time. You click on the link when it's time for the time to talk, and we'll talk that way. I've found that seems to work pretty well. So I only have 3 scheduled office hours, and that's because I'm assuming that people will want to meet outside of those times. So please feel free to email whenever questions come up. Okay. My office hours aren't in my office. They're in the tutoring center, and the room number for the tutoring center is listed there. That way, if there are multiple people with similar questions, I can talk to more, I can just fit more people around. Okay. And like I said, if any questions come up while I'm talking, please let me know and I'd be happy to answer questions. The materials you need, there is no textbook. Everything that you need for this class is going to come through the lectures and the notes. I did recommend a couple of books for people who like books, or if you want a book for future reference, like I know for the people who are pre-med taking this class, you're going to have to take a test that has physics in it, and so you're going to want something to study from possibly, and so those are some recommendations for books, but you don't need those for this class. And in fact, I think the best idea while you're doing this class is to not use any outside sources. You just need to understand what I'm saying, the way I'm saying it, the way I'm presenting it. And if you do that, I think that's the best way to get ready to do well on exams and stuff. And then if something isn't clear to you, just talk to me about it or other students in the class, and I'll help you straighten it out. You can ask me questions in lab or at office hours or email me and we'll set up a meeting. You need a calculator that has sine and cosine. Other than that, there's no real requirement. By the way, that Sham's outline of college physics that's under the recommended reference books, Sham's outlines books are really great. I don't know so anyone who hasn't seen those before, in any science class you take, there's a Sham's outline for it. And textbooks can be crazy expensive, but these things are paperback books that cost about $20, and they have tons of problems in it with solutions. Some of the solutions are full solutions, some are just answers. But so you can, if you're trying to get ready for like a standardized test or something, it's a great way to get a lot of practice. So I love those. I would recommend, if you have $20, get one of those for every science class you take. It has little concise summaries of the topic and stuff. They're just really nice. And then that other one is the Giancoli book. That's what I used to have as a required textbook, but it's expensive and I think it works better without the book anyways, but that is roughly the textbook that I kind of follow as I teach this class. The only prerequisite is college algebra. And if you haven't taken that, I guess send me an email or come talk to me. In some cases, you can get around that, but I've had people do very well in the class who've only taken regular algebra. Really, it's not the topic. It's not the content of college algebra you need for this class. It's really just comfort level with algebra, you know. So let me know if you think that might be an issue or you're concerned about your math background or whatever. The website for the class is D2L. And like I said, just get in the habit of checking that every day. It'll tell you what's new. These are the topics that we'll cover in this class. And it mostly has to do with forces, describing motion, there's nothing about electricity or magnetism. Those things come up in physics too. So this is more just like what happens when two objects run into each other, what happens when you throw something and it hits something else, what happens when, so the kind of things that you've kind of, your whole life you have experience with, you know, if you throw a baseball up into the air, it doesn't shock you what happens, and in that way it's sort of different from electricity. Like electricity is, you don't really have like hands-on experience with it. But there's sort of a downside of that I'm going to try to bring out, and that is that there are certain things that almost everybody tends to believe about the way the world works, that are misconceptions, that are wrong. And since they're sort of ingrained from all these years of thinking about the world this way, we have to be kind of conscious of going back and, telling yourself like, oh, that's how I have always thought it works, but it isn't how it works, So I'm going to try to point those things out when we get to them. Okay. The grading for this class, the grade cutoffs are most likely, it could be lower if the scores end up being lower than I expect. But the cutoffs are probably going to be 92, 82, 70, 60. That makes people a little nervous when they see the 92, 82, because it seems it's higher than you're used to. But really, I don't think you'll find that my grade cutoffs are hard to achieve. I think if anything, my grading is probably easier than other people teaching this class. The higher cutoffs just really reflect the kind of questions I ask on tests, because I try to make the test questions and the stuff that you're graded on be pretty similar to the practice problems that I've assigned. I try to be pretty clear about what I want you to know how to do, and then that tends to be, that's what I ask on the test. So I never have tests where the class average is 65% or anything, like the scores just tend to be pretty high. That grade is made up of 10% lab exams, 10% lecture quizzes, 10% daily assignments, 30% weekly assignments, 40% exams. So I'm just now going to go into each of these things and describe each of these 1, 2, 3, 4, 5 things, so you know what to expect on each of those. Anybody have any questions yet? Okay. The class itself, the tests and the homework and stuff, it's pretty much focused on learning how to do calculations, how to calculate what the velocity of this thing is going to be at this instant, what the force is that's applied to this object here. The labs are sort of separate from that, and what I'm really trying to emphasize is intuition about physics, like what is going to happen if you have a thing on a string, and sort of related to the test, that pre-test that you took in your first lab, like you have something on a string, spinning around, you cut the string. What's the object going to do? What would happen if that object hit a bigger object? And so that's what I'm going to try to get at in the labs, with a little bit of experimental design, as it says, but mostly it's going to focus on physical intuition. And for the labs, I take attendance at the labs, but the grade of the exams is just based on these three lab. The grade for the lab is just based on these three lab exams that I'm going to give, that are just kind of going to ask you to answer questions similar to what you've been asked in the labs. Since the total score for the lab exams is 10% of your grade, each one of those lab exams is worth 3 1/3% of your grade. So they're not super huge value, you know, but they add up to a full letter grade basically. Makeups, we need to agree before the lab exam. If you just miss a lab exam and we haven't talked about it beforehand, you get a 0 on that. It's not a huge deal, but it'd be best not to do that. But just like the labs, if you can't make it to one of your lab exams, look at the schedule and see if you can make it to any of the other 3 sections. You can always do that, and you don't have to tell me beforehand. Just show up and take the lab exam in a different section, and that works fine. The schedule for the lab exams is here. So look at those, see if there are any conflicts that you know of yet. And if there are, let's talk about it, and you know, we'll set up an alternate plan. But so you already know when you have to get ready for these. The next part of the grade is also 10% of the grade. That's the lecture quizzes. The exams and the problems are all, you know, numerical problem solving using equations and stuff. The lecture quizzes are just meant to make sure that you're watching all the lectures and taking notes on the lectures, and then going back periodically and reviewing your notes on the lectures. I'm not giving you a big textbook full of stuff that you have to read. I'm boiling it down into a relatively small amount of material that's in my lectures. But the trade-off is I just want you to know that pretty well. Well, I want you to go back and review it and remember what I said, you know, and that's what I'm checking in the lecture quizzes. Those are cumulative. Most of this stuff is cumulative. So when I give you a lecture quiz in November, it's not just going to be on the last couple weeks of lectures. It's going to be on stuff that I've said through the whole semester. I'm not going to try to like get you on tiny little minute details. It's going to be on what I consider to be the big sort of bullet points. But in order to get ready for those, you need to at least be going back and skimming through your notes periodically and reminding yourself what we've been talking about. And those will be, it says every class meeting. It won't be every class meeting, but between every class meeting and every 2, maybe something like that, every week or 2. I'll end this class about 15 minutes early, and I'll hand out the lecture quiz, and you'll just answer these short answer questions. And then, so that's how that'll be. I haven't lectured in person in 2.5 years, so I'm like totally like losing my voice. Bummer. Your voice gets out of shape. Any questions about the lecture quizzes? Okay, daily assignments. this is only 10% of your grade, but really this is the most important thing that you do in this class, are these daily assigned problems. So each time I assign a lecture video, or these lecture videos aren't very long, so a lot of times I'll assign more than one. But every time I do an assignment of lecture videos, there'll be a corresponding set of problems for you to work on. And those are the problems that I pointed out before that are already in D2L. And they have full solutions to them. So if you get stuck, you can help yourself get unstuck. But you should make sure that you understand the thought process of doing those problems without any help or without solutions. If you go into an exam understanding the thought process of all the practice problems, the daily assignments that have been given, you'll do well on the exam. Okay. But I do want to see you. I do want to see your work. I want to see a physical copy of your daily assigned work. Obviously, you could just take out the solutions, copy the solutions, and turn that in, and you'd get a full score for your daily assignments. You just wouldn't learn the material well enough to do well on the exam, so it's not a good idea to do that. But I will, every time I give a daily assignment, I'll have a folder in D2L, and you'll, write out the work and then either take photos of it or scan it and get a PDF of it, and then submit that to the folder that I put in D2L. So that's how we'll exchange those daily assignments. And I'm not really grading. I'm not going through and grading those problem by problem. I'm just looking at it, making sure you've done something on every problem, making sure that you're putting the time in. That's really all. Okay. Then the other types of problems are what I'm calling the weekly assignments. The level of difficulty of those is going to be similar to the daily assignments. I just won't give you solutions to those. And I'll give you a full week to work on those. And you'll submit those to D2L just like you will the daily assignments. But those I'm going to grade carefully. I'm going to go through problem by problem, more like a take-home exam kind of thing. And to get full credit, you have to understand the process, do all the steps right, that kind of stuff. I do give partial credit, a lot of partial credit actually, but you can feel, even though I'm not giving you solutions to those weekly problems, feel free to work together on those. That's fine with me. Exchange emails or whatever and talk to each other about those. I just don't want you to turn in things that you've copied from someone else. If you talk to somebody and they help you get an understanding of how to go about a problem, as long as then you do the problem yourself, that's perfectly okay. All right? You understand the distinction I'm making there? The thing that's cheating is having the same conversation with somebody in the class and then looking at their assignment and copying down what they did. As long as it shows what you're capable of doing on your own and that you're doing those problems on your own, the one that you turn into me, that's perfectly fine. And these weekly assignments, there's 16 weeks in the semester. There won't be 16 of these, but there'll be maybe 10 or something. And those add up to 30% of your grade. Also, I haven't been saying this as I've gone along, but on all of these, I drop some number of the lowest scores. All of these I've talked about so far. Well, not the lab exams, but lecture quizzes, I'll drop your lowest 2 lecture quiz scores. So like if you miss a couple of class meetings and miss lecture quizzes, then those 2 zeros just go away. Daily assignments, same thing. I think 2, I'll drop the 2 lowest daily assignments. That mostly just means you didn't turn those in, but you can have 2 that you don't turn in and it doesn't affect your grade. Although, it affects it indirectly because you need to understand that material for the exams and stuff. The weekly assignments, I'll drop the 1 lowest weekly assignment score. So if you mess one up, it's not a big deal. Then exams. There are 4 total exams. The last one is on our scheduled final period. The exams take the full class meeting. And the schedule for these exams is given here. So again, look at that schedule, and if you already know there's going to be a conflict, let me know. The sooner the better, and we'll come up with an alternate plan. Just like with the labs, if you can't make it to your exam, but you can make it to the other one, like you can't make it Wednesday, September 28th, but you can make it to class on September 29th, feel free to do that anytime. And the one sort of mulligan that I give you, if you mess up one of these exams, one of the first 3 exams, and then you do better on the final, the last exam, that last exam will replace your lowest score on the first 3. So if you really mess up exam 2, but you do all right on exam 4, then that exam 2 score goes away, and exam 4 counts as 2 of those scores. Okay. That's also if you have an unexcused absence for one of those exams, then it's a 0, but when you take exam 4, that'll replace the 0. Okay. And like all these other things, exams are cumulative. So when you take exam 3 on December 7th, that's still gonna, that still can have material on it from this week, Any questions about the exams or any of those other grading criteria? Okay. Labs, I will take attendance at labs. If you miss 3 labs, you fail the class. Well, there's sort of ways to make up labs, but yeah, if you miss 3 labs and don't make them up, then you fail the class. So you have to be at the labs. Other than that, I don't really grade the labs themselves. I just do those lab exams. Okay. And then cheating. So like I said, you can't copy other students' work and act like it was your own work. And similarly, the website Chegg, I don't know if there are other ones like it. I just know of Chegg, but it's caused some problems with cheating because it lets you like post to this website questions that you've been asked in class, and then their tutors, they call them, the people who work there, send you back solutions to these problems. And so I've had things where assignments or take-home exams or whatever have been just fully copied from these Chegg solutions. And it's not very hard to tell usually. You can see that the notation used is different than the notation you've been using in class, and a lot of times they make dumb little mistakes because they have to do a ton of these things, and And we can actually just go on Chegg and, like, if we're suspicious about something, and go and see what the solution looks like, you know. So I don't know. There might be good ways to use that website, but there are certainly bad ways to use it. And in my opinion, you'd be better off just avoiding it. And when you have questions, talking to me instead of talking to people at some random website, you know. There is the phone number to check if class is canceled, like if there's a snowstorm or something. But like I said, D2L announcements will always have that information too, but you can call that number. And then the last thing I wanted to say is Normandale has a fantastic office for students with disabilities, OSD office. And it covers a lot more than physical disabilities. So if you feel like you have significant test anxiety, or you feel like you need more time to take tests, or a certain environment to take tests, or even if you could just use help with, you feel like you're not approaching tests the right way, just contact them. They're really nice, understanding people, and they will tell you whether they have ways that, you know, can do things to help you. I love working with them, so please feel free to contact them. Okay, that's it. That's the syllabus. Anybody have any questions? Yeah. All the assignments will, yeah. And then the exams will be done in class, and I'll collect that on paper. Yep. And the quizzes too will be in class. Sure. Anything else? All right. Well, let's talk about the first topic. So the first thing we have to talk about before we can really get into any physics is we have to talk about units. So I'm going to start with unit conversion. Every measurement that you take, every scientific measurement, every measurement we take in physics has some kind of unit attached to it. If you measure a distance, your unit might be feet or meters or centimeters or something. And in this class, every unit that we deal with will be some combination of three basic types of units. There are a few others that out there, but we're not going to talk about them in this class. In Physics 2, you would talk about some of those, maybe all of those. So for us, every unit is made up of three basic types. Length, and the kind of units you see for length are inches, feet, meters, miles, so on, light years. The second basic type is time. And that can be seconds, minutes, hours, so on. And then the third one is mass. And that's grams, kilograms. In imperial units, English units, the unit for mass is a slug. You don't hear that very often, but that's what it is. We are primarily going to use SI units. So that is meters for length, seconds for time, and kilograms for mass. That's SI stands for System Internacional. Call them SI units. One thing that we're going to want to do pretty often is, just because you want to use SI units doesn't mean everybody else does. So if someone gives you measurements in hours and inches, we're going to want ways to convert to the same type of unit, but in SI units. So often we'll want to convert a measurement to a different unit of the same type. So for example, how many inches are there in 3.5 feet? Okay. You're used to doing these kind of calculations, something like this. You've done things like that many times probably. It gets a little more complicated when you have combined units like meters per second squared. How do you convert that to feet per hour squared or something? It's a little trickier, but I'm going to give you an approach that works in every case. So here's the general approach. Two units of the same type always have a conversion between them. In the example above, the two units we're dealing with are inches and feet. So the conversion between inches and feet is that 1 foot is equal to 12 inches. And since those two things are equal to each other, you can think of it as one divided by the other one. If you divide something by itself, you get 1, right? You get something that you can multiply to things and it won't change the answer. And so we'll think of 1 foot divided by 12 inches as equal to 1. And that's also equal to 12 inches divided by 1 foot. And so these are both equal to 1. And the thing about 1 is you can multiply 1 to anything without changing its value. 100 times 1 is equal to 100, right? So 100 times 1 foot divided by 12 inches is also equal to 100, okay? So we can multiply these ratios to anything we want without changing the starting value. I'm going to call these two things the conversion factors. Factors mean we're going to multiply it to stuff. And now that we have the conversion factors that we want for our 2 units, we're going to multiply the original quantity, the original measurement, by the conversion factor, and we're going to cancel units as if they were algebraic variables. Okay, so let me do this for the example that we were talking about. So we started with 3.5 feet. That's our original quantity. Okay. And we're going to multiply that by one of these conversion factors. I'm going to multiply it by 12 inches over 1 foot, and I'll explain how I know which one to choose in a second. Okay, so we're just multiplying these two things. These feet, if we think of those as they obey the rules of algebraic variables, so feet in the numerator here cancels feet in the denominator here. And the units we have left are just inches. So now we multiply all the numbers, multiply and divide out all the numbers, and the units we have left are inches, and we get 3.5 times 12, or 42 inches. So that's the answer for how many inches are there in 3.5 feet. Any questions about that? I'm also going to use a sort of a shorthand notation just to save sort of pen strokes. So when I write this, I'll actually write 3.5 feet, and here's the, the fraction bar. And instead of parentheses, I'm just going to write vertical lines there. So those vertical lines mean the same thing as parentheses. So 3.5 feet times 12 inches over 1 foot. Those go away, and you get 42 inches. Okay, but there's one issue here, and that's that there were 2 conversion factors, right? For any 2 units, you could write that conversion factor 2 different ways. And what would happen if you wrote it the other way? It's kind of chaos. So what if you use the other conversion factor? So you start with 3.5 feet. And this time you multiply it by 1 foot over 12 inches. Okay. we didn't do anything wrong. This is perfectly like legal, but nothing cancels out, and you end up with units of, I don't have that number. Could anyone have a calculator? Oh, I have a phone. What is it? Okay, thank you. So about 0.29, and then the fraction goes on and on, right? And but what are the units? The units are feet times feet. So let's say feet squared over inches. Okay, and for units of distance, I don't know what units you prefer. Might be inches, might be feet, might be meters, but I know that nobody in here wants to talk about distances in feet squared over inches. So it's not wrong, it's actually perfectly right. It's not what we were looking for. So how do you know that you want to use the first conversion factor and not the second conversion factor? And the answer is you're just always looking for one that cancels out the unwanted units. So use the conversion factor that cancels the unwanted units. So let me go back to that example and just let you see what I'm talking about. So we started out with feet, and we want to go to inches. So feet is our unwanted units. Okay, we're trying to get rid of the feet and switch it to inches. And so when we write 3.5 feet in the numerator, that means our conversion factor has to have those unwanted units of feet in the denominator. Otherwise, it's not going to cancel. So that's how you can tell which one you want and which one you don't want. Okay. Any questions? Okay, so let's do a little more complicated one. So now we've done one where we have one single unit type. But let's do one now that deals with a speed. So we'll start with miles per hour, and we'll convert it to meters per second. Okay, how do you do that if you have multiple unit types built into your unit? So let's say that we want to express 61 miles per hour in meters per second. And we're going to be given that 1 mile is equal to 1609.344 meters. Did anyone here run mile and track in high school? In Minnesota, at least, in most high schools in the US, they call it the mile a lot of times, but it's 1,600 meters. So it's 9.344 meters short of a mile. I don't know. And also given that 1 hour is 3,600 seconds. Okay, so the approach we're going to take is really the same as it was in going from feet to inches, except we're going to first multiply by a conversion factor that changes the miles to meters, and then second we're going to just keep multiplying by another conversion factor that changes from hours to seconds. Okay. So we'll start with 61 miles And in the denominator, we have hours. And it doesn't matter whether you do the distance first or the time first, but let's go miles to meters first. So we know we're going to multiply this by either 1 mile over 1609.344 meters or 1609 meters over 1 mile. So how do we know which one we want? That's right, exactly. So we want to get rid of the miles, and to get rid of these miles in the numerator, we have to have miles in the denominator. So we're going to multiply by, in the denominator, we'll have 1 mile. In the numerator, we'll have 1609.344 meters. And you can see that it works out, those two cancel. And so if we multiplied all the numbers and everything out that we have now, what we would have is 61 times 1609.344 meters per hour, okay? And if meters per hour had been the units of speed that we wanted, then we'd be done. But we want meters per second, so we still have one more step, okay? So now to go from hours to seconds, we're going to multiply by either 1 hour over 3,600 seconds or 3,600 seconds over 1 hour. Again, we're going to choose the one that cancels the hour. This hour is in the denominator this time. And so we want our hours this time to be in the numerator. So we'll multiply by 1 hour over 3,600 seconds. Now this hour cancels this one. And our units are meters over seconds. And now all we have left to do is multiply out those numbers. So 61 times 1609 divided by 3,600 gives you 27.26 meters per second. Any questions about that? Okay, what if we hadn't known that 1 hour was equal to 3,600 seconds? What if we just knew that 1 hour was equal to 60 minutes and 1 minute was equal to 60 seconds? Well, you can also follow this exact same approach just in steps. So let me do one like that. Yeah. Oh, I'm glad you brought that up, because people. So especially, I know a lot of people who take this class have taken a bit of biology and chemistry before, and especially chemistry. I guess like people say, what do I want you to do with significant figures? Like when do you round, when don't you round? And I just don't care about significant figures. I mean, I know it's a useful thing, but you've already had that in chemistry, and I just don't want to worry about it. So I won't mark you off for how you round. Just keep basically however many digits you want. It's fine with me. Yeah. Yep.
Rounding and truncation are both okay then?
Yes. Yeah. I mean, I more follow just the steps, how you're doing stuff, than the final answer anyways, so. Okay, so let's say that you have this acceleration, 38,640 yards per minute squared. I've never seen people use yard per minute squared for acceleration, but it's a fine acceleration. It's a distance divided by a time squared. And we want to express that in meters per second squared. So how would we do this? And we're going to use 1 yard is equal to 3 feet. 1 meter is equal to 3.281 feet. And 1 minute is 60 seconds. Okay, so the difference with this problem is we don't have a conversion factor in front of us that goes straight from yards to meters. We have to do it in 2 steps. Okay. So I'll start with 38,640 yards divided by minutes squared, and to do that, I'm always going to separate that out into minutes times minutes. It keeps you from making an easy mistake to make. So first, let's convert yards to meters, okay? And to do that, I'm going to go yards to feet, and then I'm going to go feet to meters. The yards, so I'm going to multiply first by 3 feet over 1 yard, because then the yards in the numerator here get canceled by yards in the denominator. Yards is an unwanted unit. Okay. And if you follow along with the cancellations, so that goes away. And if we multiply these numbers out, we have units of feet per minutes squared. And now that we're in feet, we want to go from feet to meters. Feet is in the numerator, so we want the feet to be in the denominator in our conversion factor. So the denominator has 3.281 feet. The numerator has 1 meter. The feet cancel. And now if we multiply that number out, our units would be meters per minute squared. So we've gotten it all the way from yards to meters. Okay, now we want to go minutes to seconds. The minutes are in the denominator. So we want our minutes of our conversion factor to be in the numerator. So we'll go 1 minute over 60 seconds. Notice that this minute here only cancels one of these 2 minutes. Like if you thought of that as an algebraic variable, it wouldn't cancel both of them. So after doing this, we have sort of this mixed unit of meters per second per minute. Okay, that means we have to do this one more time. So again, I'll multiply by 1 minute over 60 seconds. And now that minute cancels our other minute. And now our units are meters per second squared. Okay. And if we take 38,640 divided by 3.281 divided by 60 divided by 60, you get 9.81 meters per second squared. And that's a significant acceleration that we'll see all the time. Anyone know what that is? Yeah, that is, if you're close to sea level on Earth and there's no wind resistance or negligible wind resistance, that's the acceleration of an object in free fall. Yep. I guess let me do one more example and then we'll call it a day. Okay, let's say that we have a block like this. Let's say you can open it has hinge doors, so you can open it and fit stuff inside. And this block is a cube, and every side length is 1 meter. And let's say we're going to open this up and put in, fill it with cubes with the side length of 1 centimeter. Okay. The question is, how many of these centimeter cubes could you fit inside this meter cube? How many 1 centimeter cubes could fit inside this 1 meter cube? And we're going to use the fact that 100 centimeters is a meter. Okay, well, volume is distance cubed. So we're going to start out with this quantity 1 meter. 1 meter cubed we're going to write as 1 meter times meter times meter. Okay? Yeah. So we're going to first convert meters to centimeters, and then we'll have to do it again and do it again because we have 3 of these meters to convert. Okay? And so I'm going to multiply by the conversion factor 100 centimeters over 1 meter. That cancels the first one of these. Same thing again, multiply by 100 centimeters over 1 meter. That cancels the second one. Do it one more time. 100 centimeters over 1 meter. That cancels the last one. And now you can see that the only units that are left are centimeters cubed, centimeters times centimeters times centimeters. And all we have to do is multiply out the numbers, and 100 times 100 times 100 is 1 million of those centimeter cubes. So if you really were going to, like a cubic meter isn't really that big, you know, and a cubic centimeter isn't really that small, but if you were going to plan on filling that box, it would take a freaking long time. Anybody have any questions about that? Okay, well, we got through everything that I wanted to say about unit conversions. I'll give you something on scientific notation. I should be able to get that up by tonight. and just a lecture video to watch, and then I can give you some problems to work on. And so let me know if you have any questions. And yeah, I'll talk to you next week. Yep.
Like home exams are the
Conversion factors.
Are they going to be given or are they going to be?
Yes, and that gets at an important related question that I forgot to mention. On exams, I always give you all the equations you need and all the conversions and stuff you need. So you don't have to, it's not open book, but I'll give you all that stuff. Okay. Yeah.